Alright, for this first video for 5.5, we're just going to go over the double angle identities or formulas. We proved this in class by actually using the sum and difference identities, which we did before. But I'm just going to get right to the problems on this. You can see right here how I have this is the double angle for 2 sine, or for sine of 2 theta, which equals 2 times sine of theta times cosine of theta. The double angle for cosine of 2 theta equals this. And then if we move over to tangent, okay, and this all derives from using the sum formula. Tangent you could do a couple ways. You could do 2 tangent of theta over 1 minus tangent squared of theta, or if you already found sine of 2 theta and cosine of 2 theta, this is probably the easier way, where you could just divide these, cosine over cosine's tangent, but you have to make sure that it's 2 theta for each of these to equal tangent of 2 theta. Alright, so we're going to apply these formulas again. These formulas will be given. The main thing to remember, oops, if I move this over, the main thing to remember is that this angle is always double the angles that we use here for the formula. Alright, I'm going to skip down. I'm going to skip down to number 2. Now 1 and 2, you can see, this is where we have to use the right triangles. Let's do number 2. Alright, number 2, I want to do this one because the angle is not just in the first quadrant, it's in the second quadrant. A lot of students always have questions that, how do you draw the picture? Alright, I'm going to draw the picture actually like right down here. Okay, this is in the second quadrant, so coming out from the origin, this is our right triangle. We say this is theta because we're given sine of theta is 3/4. Now this is not a 3, 4, 5 triangle because this 4, that's the hypotenuse. 3 is the opposite side because it's sine. So what we have to do is figure out the adjacent side. Now the adjacent side, if I just do a quick little mental math using Pythagorean's theorem, it's going to be, 16 minus 9 is 7, and then you have to take the square root. So this is square root of 7. Now to use a lot of these formulas, I just have to figure out what cosine of theta is. Now since we're in the second quadrant, cosine's negative in the second quadrant. And you just use SOHCAHTOA, so cosine's adjacent over hypotenuse. So it's root 7 over this, 4. So that's this value here. Now these values right here, they circled the 3/4 for sine of theta and negative root 7 over 4 for cosine of theta. We're really going to use these, especially for A and B. So for A, if you want to find the double angle, then I use the formula. Okay, the formula which you should already have down is 2 times sine of theta times cosine of theta. And we know these values. So this 3/4 I just plug into right here, and then negative root 7 over 4 I plug right into here. So this just becomes, this equals 2 times 3/4 cosine of theta is negative root 7 over 4. So then if I multiply these, let's see here, 2 times this 3 gives me 6, and the top I get still negative root 7, so it's negative 6 root 7. And then the bottom I get 4 times this 4, which is 16, and negative 6 root 7 over 16 reduces to negative 3 root 7 over 8. So the double angle for sine is negative. Now if I want to get the double angle for cosine, this is the formula I'm using, cosine squared of just theta minus sine squared of theta. Now once you have these trig values, it's real easy. I'm just going to plug it in. So cosine, I figured out cosine theta is this, so it's negative root 7 over 4, but then you square it. And then you subtract the value for sine of theta, which is this, 3/4. We square that. So let's see, if I square negative root 7 over 4, that's positive 7 over 16, minus 3/4 squared is 9 over 16. So when we subtract that, we get negative 2/16, which reduces to negative 1/8. Now I'm going to skip down to this. I know the answer to this question. I know that theta is in the second quadrant. If you double theta, this question asks you, well, which quadrant is that in? Well, I figured out sine of 2 theta is a negative. Cosine of this 2 theta is a negative. Sine and cosine are negative in the third quadrant. Okay, and then if I want to do the last part, well, the easiest part, the last one, I could use the formula, if I want to do tangent of 2 theta, I could use, well, I guess it's, yeah, right up here. I could use this formula, but since I already know sine of 2 theta and cosine of 2 theta, as a shortcut, I'm going to use this one right here. So let's do that. This is going to be much quicker. If you don't have sine of 2 theta and cosine of 2 theta, then probably the quickest way is to use the formula. So this, I'm just going to do sine of 2 theta, which I figured out was negative 3 root 7 over 8. Then you divide this by cosine of 2 theta, which was this negative 1/8. And then if I'm dividing fractions, I keep change flip. So negative root 7 over 8 times negative 8 over 1. The 8's cross cancel, the negatives cancel out, and you get 3 root 7. And that makes sense. Tangent of 2 theta is positive. That's because 2 theta is in the third quadrant. Okay, so to do these ones, the only way you can do it, and the only way you can get started, is you have to draw a right triangle, and then once you have the trig values, plug them into the formulas.